Since ancient times, the sky dotted with the lights of stars has intrigued people, and they wanted to know if there was a center to this boundless cosmic canvas. In 1994, it looked like the Hubble telescope captured an object depicting a beautiful city with snow-white towers floating in space. People called it Heaven or Celestial City. Believers of alien civilizations were excited and even speculated the city was actually the center of our universe. But after a careful examination, astronomers declared the image fake. Scientists later explained the Hubble image captured was galaxy NGC 3079. Part of this image was cut out, photoshopped, and a celestial heaven was ready to trick the world. And even though there's nothing mysterious in the image, it has fueled widespread interest in the structure of our universe. So, does the universe have a center? Our ancestors associated it with something earthly and familiar, like flowers. Egyptians considered the sky as a lotus and its core as the center of the universe, where gods dwell. Later, the ancient Greek philosopher Aristotle came to the conclusion that the planets and even the sun revolve around Earth. And in the 16th century, Nicholas Copernicus was convinced the Earth itself revolved around the sun, which was thought to be the center of the universe. In the 20th century, more advanced telescopes revealed how vast the cosmos is. At the beginning of the century, the American astronomer Harlow Shapley made a map of the Milky Way. According to it, the Sun is just one of 100 billion stars in the dark corner of our galaxy's spiral arm. And in 1929, the American astronomer Edwin Hubble proved there are thousands of galaxies in the universe and that ours isn't unique. Today, our planet's cosmic address is very long. The Solar System, Orion Arm, Milky Way Galaxy, Local Group, Virgo Cluster, Laniakea Supercluster, Universe. This alone shows how complex and immeasurably diverse the structure of the universe is. Everything in the universe spins, from small asteroids to entire galaxies. But does the universe also spin? If it's possible to figure this out, we can calculate its center, a fixed point on a spinning object. Our planet's center of rotation is the axis connecting the north and south poles. For a basketball player spinning a ball on his finger, the center of rotation is the point of his finger's contact with the ball. But it seems that the universe has no such point. All our observations show that unlike stars, planets, and galaxies, it doesn't rotate. And this means it's impossible to find its center in a conventional way. But maybe we can find it by mass. If an object has an end, it has to have a beginning. And its center would be a point that, on average, has the same mass in all directions. However, according to the standard model of cosmology, the universe is isotropic. It's the same everywhere. Of course, the mass of galaxies differs in some of its areas, but on average, it'll be the same in huge regions of the universe, millions of kilometers in size. The cosmos is like a cellular sponge, only an extremely large one. And it doesn't matter whether you're looking at this mega sponge from Earth or from the most distant exoplanet ever discovered. The picture won't change much. The problem of finding the center of mass in an homogeneous space is impossible. Nonetheless, another component of the cosmological model, the expansion of the universe, may provide a clue. In 1929, Edward Hubble measured the speed of galaxies located at different distances away from our planet. Hubble noticed galaxies are flying away in all different directions from Earth and are accelerating in speed. And because of that, we can assume they all started moving from the same place. In ordinary life, finding the point of expansion of an object is easy. Screw a rubber sheet to the ground and then ask your friends to pull it from all sides. You'll notice that the point where the sheet is attached is the center of its expansion. But then the same can apply to the universe, right? Since astronomers can see the expansion of galaxies from Earth, then our planet should be a kind of center too. Well, the process of our universe's expansion works differently. Scientists have found that galaxies fly away when observed from any point in space, not just from Earth. The farther away from the observer, the faster galaxies move away from them. So how does this work? According to Edwin Hubble's calculation, called the Hubble constant, galaxies recede away from each other at the speed of 70.4 kilometers per second per megaparsec, or 3.26 million light-years. At 1 billion light-years away, the expansion of the universe is carrying galaxies away from us at 22,000 kilometers per second, or about 7% of the speed of light. But at 100 million light-years away, this speed is only 2,200 kilometers per second. So when looking at galaxies from different places in the universe, hypothetical civilizations would see galaxies moving away slower or faster depending on where they are. And because of that, we cannot find a center of the universe in such a way. But couldn't we measure it from the point of the Big Bang? We believe the universe was born about 14 billion years ago in the Big Bang, a massive cosmological explosion or expansion. We know that after any explosion, material expands from a specific point. It's sometimes possible to calculate such a point even with the naked eye. For example, if you take a picture of fireworks and look at the direction of light flying in the sky, it's easy to figure out where the fireworks burst out from. Does this mean we can apply this method to the Big Bang? Cosmologists believe we cannot, and not just because of the immense scale of the event, but also because it occurred when space and time didn't exist. The Big Bang happened everywhere in the universe all at once. Only then did matter begin to spread randomly throughout space. We know this because of relic radiation that emerged after the Big Bang. This is called cosmic microwave radiation, which permeates space in all directions. Its approximate temperature is 2.7 Kelvin, but in some regions it can be colder. In cosmic voids, the temperature of relic radiation is a fraction of a degree lower. But no deviations from the average temperature have been found in larger regions of space. And if the Big Bang did have an epicenter, it would have been much hotter closer to the epicenter than elsewhere. Scientists compare the universe expanding after the Big Bang with a two-dimensional ball with points drawn on its surface that symbolize galaxies. If we inflate the ball from the inside, it'll grow in all directions equally, and it won't have a specific center. The dots on it will become evenly distant from each other, but the problem with this comparison is the universe must have an end. But what if the universe is infinite? Scientists are finding more and more evidence for this idea. And if this is the case, we'll never be able to determine the true size of the universe, and because of it, its center. Accelerating faster and faster relative to the observer, at some point, the expansion must exceed the speed of light. And when this happens, we would find ourselves surrounded by an event horizon we wouldn't be able to look beyond. But what about the electric charge of the universe? Would it help us to find a center? Modern science tells us that the distribution of the charge of the universe is, on average, homogeneous. There are equal numbers of objects with negative and positive charges in huge regions of space. And as a result, the total electric charge of the universe is zero. So we won't be able to detect any special point in this way either. So far, everything indicates the universe has no center. And of course, it does not rotate. However, an international team of astronomers claim they might be able to pinpoint a center of our universe with the help of the so-called dark flow. Scientists made this hypothesis after studying galactic clusters from data collected by the Wilkinson Microwave Anisotropy Probe. They noticed that about 1,400 galaxies between the Sales and Centaurus constellations behave abnormally. Unlike others that travel rather randomly, these cosmic objects move in the same direction. According to astrophysicists, galaxy clusters are gravitationally attracted by something with an extreme mass. This force drives the dark flow through the whole observable part of the universe and even beyond its limits. And it does so with an insane speed, not less than 600 kilometers per second. Cosmologists suggest that this flow gradually pulls in more and more galactic clusters, and their point of attraction could be the center of the universe. Scientists believe that this could be a black hole, and if so, it's so huge it has no analogues in the known universe. Perhaps the black hole is preparing for a new Big Bang. For this to happen, it would need to pull in and compress all the matter and energy of the universe into an indivisible singularity point. An interesting idea is that through the center of this black hole, our universe could flow directly into some parallel world. Which hypothesis seems more plausible to you? Let us know with a comment, and to make sure you don't miss out on anything mind-blowing happening in our universe by subscribing. Thanks for watching.